Hi students, if you like this video, please subscribe and share it. Don't forget to like it. Now I am going on. Topic is mathematical reasoning. Now discuss about truth table. Okay, now here n simple statements are given. Then making a table. Now n simple statements are given. Now making a table. Now number of rows is equal to number of rows is equal to number of rows is equal to 2 power n. Okay, now here first for single statement P given. Now number of rows is equal to 2 power 1 is equal to 2. Now single statement P are given. Now here number of rows true, false, only 2 rows. Okay, now first two statements P, Q are given. Now number of rows is equal to 2 square is equal to 4. Okay, now two statements P and Q. Now PQR two statements are given, P and Q. Now here number of rows are 4. Okay, now true, false, true, false. Okay, now here number of rows 1, 2, 3, 4. Okay, now here two statements P and Q are given. Therefore, number of rows is equal to 4. Now three statements third point for three statements PQ are given. Now number of rows is equal to 2 cube is equal to 8. Okay, now here statements P, Q, R. Now here three statements P, Q, R. Now true, false. Okay, now true, false, true, false, true. Now true, false. Now true. Okay, now false. Now false, true. Now false, true, false. Now false, true, false. Now false, true. Now false, true. False, true. Now here number of rows 1, 2, 3, 4, 5, 6, 7, 8. Now here three statements are given. Number of rows is equal to 8. Next, truth table for conjunction. Now here first connective conjunction. It's one end. Okay, let P and Q are two statements. Now P and Q. P and Q. Now truth table for conjunction. Now here P, Q. Now P and Q. P and Q. Now here true, 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 false, false, true. Now false, false. Now here P and Q both are true. Now P and Q are true. Otherwise remaining are false. Now true, true means here true. Remaining all are false. Here also false. And here also false. Now here also false. Now note, when PQ both are true, when PQ both are true, then P and Q true. P and Q is true. Otherwise false. Otherwise false. Okay. Now P and Q both are true. P and Q true. Otherwise remaining are false. Okay. Next connective, bijection. Bijection. Second connective, bijection. Truth table for bijection. Now here R. P, R, Q. P, R, Q. Okay, now here P, Q, P, R, Q. P, R, Q. Now true, 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 false, false, true. Now false, false. Okay, now here when P, Q, B both false, now P, R, Q are false. Otherwise remaining all are true. Now here true, and here also true, and here also true, here false. Okay. Now here key point, when PQ both are false, then PRQ is false. Otherwise true. Otherwise true. Next one, conditional. Conditional or implication. Implication. Now P implies Q. P implies Q. Now truth table for conditional. Now here P, Q. Now P implies Q. P implies Q. Okay, now here first true, 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 false, false, true. Now false, 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 false. P is true, Q is false. That only false. Remaining all are true. Remaining all are true. Now remaining all are true. Now here key point. Now P implies Q. P implies Q is the statement. Is false. Is false when P is true, Q is false. Q is false. Otherwise true. Okay, now here only P is true, Q is false. Now P implies Q is false. Remaining otherwise true. Okay, next to find Q implies P. Q implies P. Now Q implies P means, now Q implies P. Okay, now here Q to P. Now true, true, and here also true. Okay, now false, true, true. Okay, now true, false. True, false means false. Next to false, false, true. Okay. Next one, biconditional or by implication. Fourth one, biconditional or by implication. Biconditional. Biconditional or by implication. Now, truth table for biconditional. Truth table for biconditional. Now, P double implies Q, or if and only if Q. Now, P, Q, P double implies Q. Okay, now truth table for biconditional. Here true, 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 false, false, true. Now false, false. Here biconditional, here statement P double implies Q means either two tables true, true, false, false, true. Remaining here false. Now true, true, true. A false, false, true. Remaining are false. Now here key point, P double implies Q is the statement, is the statement. Now here P double implies is the statement when P and Q both are true, is the statement is true when P and Q both are true or false. P and Q are same. P and Q are same. Otherwise false. Now here P double implies Q means both are same. Both are same means here true, true. Truth values are. And here also false, false. Both are same means P double implies Q is true. Otherwise false. Now next find Q implies P. Q implies P. Now Q implies P means, okay, now here both values Q to P. Here also true, true. Now here also true. Next false, true, false. True, false, false. Now false, false. Here both are same. Therefore true. Truth table for negation P. Negation P. Now here negation P. Okay, now P and also negation P. Okay, now P is true, negation P false. Negation P means not P. Now here false and here also true. Okay, now negation of negation P. Negation of negation P. Okay, now truth table for negation of negation P. Okay, now here P, negation P, negation of negation P. Now here true, negation P is false. Here false, this one true. Okay, now here negation of negation P. Here false means this one true. Okay, now here true means this one false. Therefore, P is equal to negation of negation P. Here now according to truth table, here P is equal to negation of negation P. Next, truth tables for tautology and contradiction. Now what is a tautology? A compound statement is always true is called a tautology. What is a contradiction? A compound statement always false is called a contradiction or falsity. Okay, now truth tables for contradiction and tautology. Okay, now tautology. Contradiction or falsity. Okay, now truth table, now here P. Negation P. True, negation P false. Now here false, true. Next one, PR negation P. Next one, P and negation P. Okay, now PR negation P means second connectivity. Now both here P and Q are two statements. Now both are false means now PRQ is false. Remaining all are true. Now here also true and here also true. Next, P and negation P. Now first connectivity. Now P and Q are two statements. Now P and Q both are true means now P and Q is true. Remaining all are false. And here also this one false, this one false. Now here PR negation P is called a tautology. Now here PR negation P is a tautology. Now P and negation P is a falsity or contradiction. Contradiction or falsity.